Hey guys, welcome to the session by K21 Academy. In this session, we are going to discuss about multi-container pods and its design patterns. Now let us take a quick glance at the agenda. Firstly, we will be introduced with multi-container pods and its design patterns. And then we will try to understand sidecar pattern. Post that, we will understand about ambassador pattern. And finally, we will be going through adapter pattern. So we have taken a clip from one of our certification training program on Docker and Certified Kubernetes Administrator, which is CKA. And in this clip, our expert will talk about multi-container pods and its design patterns.
So till now, we have seen pods which have single container in it. But yes, we can have pods which can have multiple container residing or wrapped up by the same pod. And what would be the use cases? Like for example, I want to have several replicas of my Nginx pod. I would be deploying one replica of the Nginx container wrapped up by a single pod rather than having 5 replicas of my Nginx container residing on the same pod. When we say multi-container pod, it's not that we are talking about the replicas. This is a bad design. Rather, we would have 2 different sorts of containers. Like one is a Nginx container, another is a container which is helping us populate the Nginx web servers, the entire static database, the static web server page you can think of. So one is writing to the volume, the Nginx web server is reading from the volume and showcasing that entire data which is residing in the volume as a web server's web page over here. So when we talk or when we say that we have multiple containers in the same pod, they are not same containers. They are entirely different applications. They would be 2 different sorts of applications which are bound to sit together. And if we don't keep them together, then they would have some like effects. They would not work properly, could be a possibility. So let's understand when we design a pod and there are multiple processes, or we had discussed about microservices that form a cohesive unit together. They got to sit together, otherwise they would not work. In those cases, we have some limitations like they are the ones, those who have to share some resource. They are the one those should have dependencies. They can't communicate with each other if they are sitting far apart. Because when we are talking about pods having one container each, you can't guarantee that the pods would reside in the same server or they would reside in the same region or the zone. They can be distributed across anywhere in the cluster. There could be a possibility that my application has a limitation with the latency in the network, or any sort of limitation like both the microservices got to have the same IP address. So pod has an IP, containers have port. If 2 different containers got to have the same IP, I got to wrap them by the same pod. When we say pod, that automatically means that we are talking about co-located, co-scheduled containers, and whatever happens, they would be scheduled or they would be located on the same server or the virtual machine or the host. When we are thinking about creating them, when we are talking about terminating them, it's all been done together. The life cycle get tied up together. They come up together, they work together, they die together. And because they are sitting together, they are so tightly coupled as a single unit. And when we say pod, we have discussed that pod is the smallest deployable, creatable, destroyable unit in case of Kubernetes. So when I have 2 containers or more than that sitting inside the same pod, they have the complete life cycle tied up together. So here, if you look into this example, there is a file puller type of application which has a capability of populating the data which the web server can showcase. And consumers are those who are actually using the web servers content, or those who are actually visiting those web servers. So one guy is populating the data, other guy is actually reading or showcasing that data. So in a pod, I can have a volume. The volume can be mounted inside both the containers. One is writing to that volume, one is reading from that volume. And when we say this volume, it's that the PV and PVC, which we have discussed about. So this is all about the multi-container pod. Now, there are different types of use cases in which you can keep multiple containers inside a pod, and that is the reason we have different sort of patterns. So we will discuss the patterns one by one. When we say multi-container, that itself says that it's a pattern, and in that you can segregate different sorts of pattern as well. So when we are talking about multiple containers, instead of that, if I would have multiple processes running in the same container, one container having multiple processes, what would have been the drawback? The drawback would have been that it is really difficult to troubleshoot. One process leads to the destruction or troubling the other process would have happened. Now, because containers have isolation, and I keep them separate inside two different containers, troubleshooting becomes easier for me. Even though I have that pod limitation many a times, inside the pod, we can just restart the containers as well. That liberty we have. But if two processes are sitting inside the same container, it becomes very difficult to manage their entire life cycle and debug the issue. So when we thought of making multi-container pod, we understood that they are tightly coupled applications which got to get co-located or managed together. But we don't want to tie the entire process to each other. We want a level of isolation, and that is the reason we came up with different sorts of patterns. Like a sidecar type of pattern is called when a pod is helping the other pod to do something. Like we understood that one is populating the data, other is showcasing that data. That is like a sidecar type of pattern. Another pattern is an adapter type of pattern where one is actually simplifying the output, whatever we have from the actual application, so that it can be understood by a third-party application. And if I have 10 applications, say app 1, app 2, app 3, everyone is giving an entire different format of data, then the third-party application to do the matrices analysis or to do the any sort of analysis becomes difficult. So this adapter type of container, what it does, it takes the data and makes it in a format in which the third-party application is expecting. So this helps us adapt to I would say adaptability increases for that application. So that is the reason it is called as adapter type of container or adapter type of pattern, sorry. And the third one is ambassador type, in which the main application doesn't have the other applications talking to it directly. Rather, the ambassador container would be proxying the data outside or proxying the connections for it. So you don't connect directly to your main app, rather you connect to a ambassador container which proxies the stuff to us. So this is few or the different sorts of multi-container pattern. We will deep dive into each type of pattern and try and understand what each of the pattern gives us, the advantages we have, and when to think that it is a sidecar type of application. These two applications, I'll implement it as a sidecar pattern, or these sort of applications I got to implement as an adapter pattern or an ambassador pattern. We got to understand that. Then only you can go ahead and design your applications well. So this was all about the introduction to multi-container pattern. We will discuss about our first multi-container pattern, which is sidecar pattern. It is one of the mostly or most commonly or most widely used type of multi-container deployment. In this, the main container does the actual application, heavy lifting type of thing. And the second or the side container just enhances the some of the capabilities or some of the actions which the main container can do. So it's just an extension which it provides. Advantages what we get, like in case if the sidecar container and the main container, first the isolation is attained because we have two different containers deploying those applications. We can allocate resources separately for them. We can say how much the sidecar container would need or how much it will go up to. And we would specify the resources separately for the main container as well. The sidecar container can be, you can think of a container like it can be used with different sorts of other application, and the sidecar can work with app A also for doing the same sort of thing, work with app B also for doing the same sort of thing. So I'm actually not changing the original functionality of my app A and B. Like for example, you have two different sorts of application. Say app A is there and app B is there. Both have to do some sort of work. Could be a possibility that they have to read the data from a place. So there is a volume and they got to read the data from place and showcase the stuffs. Here also there is a database. This guy reads from it. This doesn't have the logic of writing into the database. It can read through and it doesn't write. So I'll put the arrow in the opposite direction. It just reads the data from here and then showcases that data or works on that data, manipulates that data. But writing that data is not the work of application A or application B. It's work of some different sort of application. Let me pick up a different color altogether. There is a guy or there is an application, say called app C, which has the capability of populating these things. Then in both the places, I am running the same sort of application. This is a different pod, right? And rather I should draw like this. This is a different pod and this is a different pod altogether. I am not changing the functionality or any logic which is being worked inside app A or app B. No logic on this is changed. Rather, a logic is implemented in a different third-party application which can do the work. And this guy can do the work for any sort of application. It can help app A, it can help app B. So this is not the main functionality. Rather, it is extending the functionality of app A and app B both. And if you see over here, few important things. It is like reusable. It can be paired with any other different types of applications as well. Different types of main containers can use it. And if I'm failing, I have a containment zone or a boundary. I understand whether my main application is failing or my extended logic is failing over here. And if I want to make any upgrade or roll out any versions of my applications of the main. So here, if you see, it is like just rolling out. Its containers can be deployed independently, right? So images are tied up to the container, not to the pod. So containers are the unit of deployment over here. They can be upgraded or rolled independently as well. So that's the logic behind the sidecar container. If you look into the sidecar pattern, actually, you will have a pod, you will have a sidecar container, you will have the main application container, any file system type of thing, which is actually helping my original application to work. That is called as a sidecar container. And that's the reason name is also called as sidecar. So this application is writing few things which the main application is utilizing and my users are using that data. So such type of implementations are called as sidecar pattern. Extended logic implemented in a container sitting next to it or side by of it. That's the reason it is called as a sidecar. if you look on a node, I have a pod called as MC1, and container 2 is populating the HTML index.html web page. It's writing it to the volume, and the container 1, the first container, is actually reading from it. How do you write that in terms of a YAML file? If you see, nothing much is different. Either you write it as a deployment or you write it as a kind pod. Actual changes are within this container's definition over here. So you have the API version, you have kind pod, you have metadata, you have name of the pod. In the specification sections where you have container, I'll come to the volume section in a while. You have the container definition. There are two containers, if you see, container 1 and container 2. And here the first container comes up with Nginx image. It is volume mounting something called as HTML volume. The path is user share Nginx HTML. And this HTML volume is an empty directory type of volume. So it will go off when the pod is deleted, right? If pod is deleted, the empty directory would be that's like a temporary file system we had discussed. And the second container's work is like to populate that index.html content. If you see, it is coming up with a normal Debian operating system image. It is also mounting the same volume, which is HTML. The mount part here is /HTML. And as soon as this container starts the initial, if you see, it is executing something in the initialization sequence, right? It is starting this shell as the primary process and it is executing a command. It's an infinite while loop over here. While is always true. So continuously with a 1 second sleep, it would be putting the date inside this HTML file. We are trying to showcase a very simple logic over here. Just imagine very complicated website also, if you're trying to populate, it's okay with it. Here, two containers have to reside together. That logic has to be understood. So we are saying that this infinite while loop would be continuously running. This container sleeps for 1 second, writes the date into index.html. And because this container has also mounted the same HTML volume, index.html, which is residing in this HTML volume, is showcased or it is served from this path. And if you go and open the website, that would show up exactly that every second the date is mentioned. So this is all about the sidecar pattern. We would do this particular lab and understand how this lab exercise work. But for important highlighting, volume is there whose name is HTML. Second container has mounted in /HTML and has implemented an infinite while loop to populate the data in this HTML volume. And the first container is mounting the same volume and it's reading through it and showcasing the web page. So this is the logic behind the sidecar pattern. We would learn about another type of multi-container pattern, which is ambassador pattern. So in ambassador pattern, one container is in charge of proxying the connections for the actual application, and that is called as an ambassador container. So your application would not be directly communicating with other application or with the outside world. Rather, there is an ambassador container which would be proxying the connections to other services. So this ambassador container acts as a client proxy and it will proxy the connections to the entire world. So if you have a pod, you have an actual application container, you have an ambassador container as well. And this application container, ambassador container, can talk to each other because they are sitting or residing in the same pod and they can just call each other from the local host itself, right? Remember that pod has an IP and containers have a port numbers to talk. So they feel like they are residing on the same machine and they can talk to each other with a local host combination itself on a different port number altogether. And this ambassador container actually proxies the connection to the other services which are trying to communicate with the app container. So let's see how do we implement this. You have a pod called as MC3. It has two containers. One is your web application, and the second one is like an Nginx controller type of application, which listens on port 80. It gets the connection and it forwards the connection to the actual application, which is listening on port number 5000. So connections would be coming over here, the actual request, and then it would get forwarded to port number 5000, which is actually this web app. So now if you see, I'm not exposing my actual web application to the client, other services. Rather, this is the ambassador container which is getting exposed. How do I write this? Here also, we have taken kind pod, the metadata, the name of the pod, the label of the pod. In the spec section, you have two containers. One is the web app container, which is coming up with a proprietary website application image. And the second one is an Nginx, plain Nginx container. And we have taken Alpine Nginx image. If you see, the port number on which this ambassador container is listening is port number 80. And here the port forwarding part, or sending the packet or proxying the thing, is that logic is implemented inside the Nginx configuration file. And we have discussed that the configuration file can be mounted inside the container as a volume using config map. So if you see here, there is a volume called as Nginx proxy config, which is mounting a config map, which is actually a configuration map called as mc3-nginx-conf. That get mounted inside this, and this is the mount part. When you have that mount part, the sub path over here is nginx.conf. It will be using that particular file name. So whatever configuration we are writing, that gets populated in nginx.conf. Let's see the configuration file. These are few of the important things which we need to understand, and it has to be set as right logic. Let's look into the configuration map. So config map has the name of the config map and the data. Data is the Nginx conf file. So whatever you write in this, that would be available in /etc nginx nginx.conf. Over here, if you look, you are saying the user is Nginx, and here the important parameters is the server is listening on port number 80 and it is proxying the packets to HTTP web app container. And here, if you see, web app is listening on port number 5000 on the local host itself. So whatever packet is received on port number 80, that would be sent to web app. Web app is the name of the container which is residing on the same server on port number 5000. So these are the important things we have to understand so that we can go ahead and implement our ambassador pattern. So in this, if you see, all the connections are just coming to the Nginx container, and from there the Nginx container is like proxying the connections for it. No containers or outside services are actually talking to our original app container. So this is all about the ambassador type of multi-container pattern. We would discuss about multi-container pattern, which is the adapter pattern. So in this, normally a container has to adapt to a third-party application. And because we don't want to change the logic residing inside my actual application container, I would be implementing, or I would be making a side-by container called as adapter container. It's also like a sidecar pattern itself, but it is helping us adapt to a situation, and that's the reason it is called as adapter type of container. In such situation, what happens, like for example, let me quickly clean this board. We have a lot of logging and monitoring tools which grab the information like matrices and all. There is an application called as Prometheus. It can collect the matrices from different sorts of application and it can showcase it over here, or it will have all the matrices. We can even fit a dashboard like Grafana and all with it, and we can showcase the matrices in the terms of dashboard. Prometheus collects that and has its like analysis, or you want to dump everything, it's like a single place where you can get all the information. So here data is coming from app A, it is coming from app B, it is coming from application C. But it's not necessary the format in which this guy is giving the output that is understood by Prometheus. This may be writing the output in a different format. This may be writing in an output in a different format. I don't want to change the logic today. Today I'm using Prometheus. Tomorrow I may use something else. So if I change that, my application logic gets changed. I don't want to do that. Rather, I'll do a plus adapter. This has the logic of receiving information in any format, but making it in a format so that Prometheus can understand. So this guy can be called as a Prometheus exporter. It helps us in exporting the data to Prometheus. And I can tie up that particular container with all the containers because it has the ability or logic. Take input in any format and output in a format in which Prometheus is working. Tomorrow, instead of Prometheus, if I'm using something else, I just need to remove this adapter and use another adapter. My applications are not getting affected at all. So I'm just changing this definition, removing and fixing another adapter, any other different type of exporter, and using that. So this adapter type of container has helped me to adapt to a third-party application which helps us in performing better or analysis better, right? So here if you look, it's this is the type which is normally widely used for any other logging or monitoring type of tool adaptation when we happen. We don't want to change the pattern in which my application is actually writing or the standard format in which my application is writing. Rather, I have an adapter container which will receive the raw logs or raw matrices and convert that in a format in which my logging or monitoring tool is actually understanding. So here if you see, my Go application is there, my Python application is there, my Java applications are there. They can communicate with each other and there are a set of matrices which are coming. Prometheus is just talking to the adapter one. The data is taken by the adapter container and they change the format in a way that the Prometheus understands. So that the adapter guy is called as a Prometheus exporter. So if you see, we have two sort of files over here. In the pod, the kind pod, here we have two different containers. One is the web server container and one is the adapter container. Web server container has come up with Nginx image. It has a standard port number 80. It has done a volume mount over here. The mount path mentioned is /etc nginx configuration file, which is, and the name of the volume mount is given nginx conf. If you see, this conf is actually the config map over here. The config map file also I have it over here. So this is the standard configuration which you have. Nothing to do much with the adapter type of container. This is standard Nginx configuration which we have. But important point here is the second container which is called as the adapter. The name, if you see, it's called, we have mentioned this as adapter container. Image, it has come up with Nginx Prometheus exporter. And here you would see that it comes up with and listens up on the port number 9113. So your container will actually showcase the matrices which Prometheus can't understand. But if I want to go into 9113 and look into the pattern of the matrices, I should be able to grab the matrices in a better way. So my original application doesn't show me the matrices, doesn't allow the connections from anywhere else. It just allows the connection from the local host. And it just allows, if you see here, Nginx status would be projected over here. And it allows connection from only the local host. Rest all it is denying. So this guy can go and grab the status, and we would grab the status from here if you look over here. And here the arguments, if you see, this is the place wherein the Nginx status it is grabbing, and it is listening on 9113. So we can connect to the adapter container in 9113 and get our Nginx status over here.
So we have put down everything about the certification, including the basic concepts that one should know everything like microservices and Docker, networking, storage and app stack in Docker, Kubernetes architecture and installation, security, troubleshooting and high availability, networking, deploying, application stack, and advanced networking. In this 12-week roadmap, we take you from basics to advanced level along with the tips and resources for clearing the certification exam. We also have a separate team working for CV preparation and on-job support. So if you want to become Docker and certified Kubernetes administrator and want to learn right from basics to expert level, then we have a comprehensive step-by-step training for you that includes hands-on labs, including exam preparation, and the most important part, 1 year on-job support. If you are interested in this program, then I would highly recommend you to attend our free class which covers most of the topics like why learn Docker and Kubernetes. And under Docker, you will be learning what is container in Docker, Docker architecture. And under Kubernetes, you will be learning what is Kubernetes, why to use it, Kubernetes architecture and pods, highly available and scalable applications, and many other topics. So if you are interested in attending this free class, you can visit k21academy.com/kubernetes02.